Imagine I show you 1000 pictures of cats and dogs. I don't tell you every rule, like cats have pointed ears, dogs have bigger noses, cats have this shape, dogs have that shape. Instead, I simply give the computer thousands of examples and tell it, this is a cat, this is a dog. After seeing enough examples, the computer can look at a completely new image and say, I think this is a cat. But here is the fascinating part. What exactly happened inside the machine? How did numbers turn into a prediction? How did the model know that it was wrong? How did it improve itself? And most importantly, what does learning actually mean in machine learning? In this video, we are going inside that process step by step. By the end, you will understand the fundamental loop behind machine learning. And let's see how this actually works. When we say a machine is learning, it doesn't mean the machine is thinking like a human. It means something much more specific. The model makes predictions, compares those predictions with what actually happened, measures how wrong it was, and then changes itself so that future predictions become better. So, machine learning is essentially an iterative improvement process. The model makes mistakes, learns from those mistakes, and gradually improves. Let us use a simple example throughout this video. Imagine we want to build a model that predicts house prices. We have historical data. For every house, we know things like the area, the number of bedrooms, the location, the actual selling price, the historical information becomes our training data. The information we give to the model is called features. For example, area, number of bedrooms, location, age of the house, these are the inputs. And the value we are trying to predict is called the target or sometimes the label. In our example, the target is the house price. So we can think of it as features go in, target comes out. Here is something very important. Machine learning algorithms don't understand a house the way a human does. They work with numbers. So, real world information needs to be represented numerically. For example, area could be 1500, bedrooms could be 3, age could be 5. The model works with these numerical representations to discover relationships. This is one reason data preparation is such an important part of machine learning. Now we give these features to our machine learning model. Think of the model as a mathematical function. It receives inputs and produces an output. For example, we give it 1500 square feet, 3 bedrooms, and a particular location. The model might predict the price as 95 lakh rupees. But at the beginning, the model doesn't necessarily know how to make good predictions. That's where training begins. Let's imagine this is the model's first attempt. The actual price of the house is 1 crore, but the model predicts only 65 lakh rupees. That's a poor prediction. So we have a very important question. How does the model know that rupees 65 lakh was wrong? We need some way to measure the error. And that brings us to one of the most important concepts in machine learning. The model uses something called a loss function. A loss function measures how different the prediction is from the actual answer. If the prediction is very close to the actual value, the loss is small. If the prediction is very far away, the loss is large. So you can think of loss as a score that tells the model how badly did you perform. Low loss is generally good. High loss means the model needs improvement. The basic process is first the model makes a prediction, then the loss function compares that prediction with the actual answer, and finally it produces a number representing the error. For example, actual price is 1 crore rupees, prediction is 65 lakh rupees. The loss will be relatively large. If the model predicted 95 lakh rupees instead, the loss would be much smaller. At a very basic level, we can think about error as the difference between the actual value and the predicted value. Suppose the actual price is 100 lakh rupees and the model predicts 65 lakh rupees. The difference is 35 lakh rupees. Of course, real machine learning model usually use carefully designed loss functions rather than simply using this raw difference. For example, regression problems often use mean squared error or MSE. The important idea is the loss function turns prediction quality into a measurable number. One popular loss function for regression is mean squared error. The idea is simple. We calculate the difference between the actual value and the predicted value. Then we square that difference. And finally, we average the squared errors across examples. Why square the error? Because it removes negative signs and also penalizes large mistakes more strongly. A prediction that's slightly wrong gets a small penalty. A prediction that's very wrong gets a much larger penalty. Now we get to the heart of how the model actually learns. A model usually contains parameters. For a simple linear model, you can imagine something like price equals a weight multiplied by area, plus another weight multiplied by bedrooms, plus another weight related to location, plus a bias. Don't worry about memorizing the equation yet. The important idea is the model has adjustable numbers. These numbers control how strongly different inputs influence the prediction. So, what does training actually mean? Training means finding good parameter values. The model starts with some initial values, it makes predictions, we calculate the loss, and then we adjust the parameters so that the loss becomes smaller. So, when someone says the model is learning, a useful mental note is the model is adjusting its parameters to reduce prediction error. The model follows a loop. Step 1, make a prediction. Step 2, calculate the loss. Step 3, adjust the model's parameters. Step 4, make another prediction and repeat again and again and again. Over many iterations, the model hopefully becomes better at making predictions. Now we have another problem. Suppose our prediction is wrong. How does the model know which parameter to change? And more importantly, should it increase the parameter or decrease it? This is where calculus and gradients become important. A gradient tells us how the loss changes when we change the parameters. You can think of it as providing a direction for improvement. One of the most important optimization algorithms in machine learning is gradient descent. Imagine you are standing on a mountain. Your goal is to reach the lowest point in the valley, but you can't see the entire landscape. You can only look around yourself and determine which direction slopes downward. So you take a small step downhill, then check again, and then take another step. Eventually, you hopefully reach a low point. Gradient descent works with a similar idea. Instead of minimizing altitude, we are trying to minimize loss. Gradient descent calculates the gradient of the loss with respect to the model parameters. Then it updates the parameters in the direction that should reduce the loss. The basic idea can be represented as new parameter equal to old parameter minus learning rate into gradient. Don't worry if this equation looks unfamiliar. We will study the mathematics in much more detail later in our mathematics for machine learning series. For now, remember the intuition. The gradient tells us the direction and the learning rate tells us how big a step to take. The learning rate is extremely important. Imagine we are walking down a mountain. If our steps are extremely tiny, we will eventually reach the bottom, but it could take a very long time. If our steps are extremely large, we might jump past the lowest point and keep bouncing around. So we need an appropriate step size. That's what the learning rate controls. A very small learning rate can make training slow. A very large learning rate can make training unstable. Let's put everything together. One training iteration looks like this. We take data, the model makes predictions, we calculate the loss, we calculate gradients, we update the parameters. And now we have a slightly improved model. This entire process can happen again and again. Imagine that our initial loss is 100. After several iterations, maybe it drops to 65, then 30, then 12. The exact numbers are just for intuitions. The important point is that during successful training, the model should generally learn parameters that produce lower loss on the training objective. This repeated process is how the model gradually improves. You will often hear another term in machine learning, epoch. An epoch means the model has gone through the training dataset once. For example, if we have 10,000 training examples and the model processes the entire training dataset once, that's one epoch. If it processes the dataset again, that's the second epoch, and so on. Multiple epochs allow the model to repeatedly learn from the training data. In practice, we often don't process the entire dataset in one giant operation. Instead, we divide it into smaller groups called batches. For example, suppose we have 10,000 training examples. We might process 100 examples at a time. Each group of examples is a batch. This is especially important when datasets become very large and memory is limited. Let's make the terminology clear. Suppose our dataset contains 10,000 examples and our batch size is 100. That means we have 100 batches. Processing one batch and performing one parameter update is commonly called an iteration or training step, depending on the framework and context. After all 100 batches have been processed, we have completed one epoch. So remember, batch equal to group of examples, iteration or step, one update using a batch. Epoch equal to one complete pass through the training dataset. Now we can finally see what learning really means. We start with training data, we represent that data using features. The model uses those features to produce a prediction. The prediction is compared with the actual answer. A loss function measures how wrong the model was. Gradient tells us how the parameters should change. The parameters are updated and the whole process repeats. That repeated optimization process is the core of how many machine learning models learn. The goal is not simply to memorize the training examples. We want the model to learn useful patterns that allow it to perform well on new, unseen data. This ability is called generalization. For example, if we train a model on thousands of houses, we don't only care whether it can predict the prices of those exact houses. We want it to predict the prices of a house it has never seen before. That is the real test. So, there are two different things we care about. First, can the model learn from the training data? And second, can the model use what it learned to make good predictions on data it hasn't seen before? The second one is especially important because in the real world, our model will constantly encounter new data. And this leads us to one of the most important problems in machine learning, overfitting. A model can become extremely good at the training data but perform badly on new data. It's almost like a student who memorizes the answers to practice questions but doesn't understand the underlying concept. The model has learned the training examples too specifically. It hasn't learned the patterns that generalize well. We will study this deeply in a later episode. Let's bring everything together. Machine learning training is essentially an optimization loop. Data goes into the model makes a prediction, the prediction is compared against the actual answer. The loss tells us how wrong we are. The gradient tells us how the parameters should change. The parameters are updated and we repeat this process many times. Hopefully, the result is a model that makes useful predictions on new data. If you remember only one sentence from this entire video, remember this. Machine learning learns by adjusting model parameters to reduce prediction error. That's the foundation behind a huge amount of machine learning. Later, we will see how this idea appears in linear regression, neural networks, deep learning, and even modern AI systems. Let's quickly recap what we learned. We started with data. We understood features and targets. We saw how a model generates predictions. We learned that the loss function measures prediction error. We saw that models contain parameters that can be adjusted. We introduced gradients and gradient descent. We learned about learning rate, batches, iterations, and epochs. And most importantly, we learned that the goal isn't memorization. The goal is generalization, performing well on new data. Now that we understand how machine learning learns, there is another question that almost every beginner asks. What exactly is the difference between artificial intelligence, machine learning, and deep learning? Are they the same thing? Is deep learning a type of machine learning? And where does generative AI fit. That's what we will break down in the next episode. I'll see you there.